Number one. We took 45 and divided it by 12. Because there's 12 inches in a foot and came up with 3 feet and had 7 inches left over? About 9 inches left over.
Yep.
9 inches left over? So 3 feet, 9 inches? Okay. Number 2, they started out at 3:12 p.m. on Tuesday. 5 hours and 24 minutes later, what time would it be? Valerie?
8:36 p.m.
Yes, 8:36 p.m. 8:36 p.m. Questions on number 2? Number 3, they multiplied, they moved the decimal point over 2 places and got 46 and 48 hundredths. Any questions on that? Number 4, they added the numerators and they added the denominators and got 8 and 2/6. Any questions on that?
I didn't get that. I didn't go up. I just made 1/2, 2/4, and then added it.
All right, do we just add our denominators together? No, we do not. We do not. So 1/2 equals 2/4. So it would be 3 and 2/4 plus 5 and 1/4, and you got
8 and 3/4.
8 and 3/4 would be correct. 8 and 3/4. Number 5. 18 kids went to the game. A third of them got popcorn. How many kids got popcorn?
6.
And how'd you figure that out?
One, because there were 18 kids, so I divided 18 by. Well, I know that 6 went into 18 3 times.
Okay, so you divide it into 3 groups. And there were 6 kids in each of those groups. Number 6 is right here. I'm curious where the 4 came from. Who did this? Audra, where did the 4 come from?
It came
I like your work, but where did the 4 come from?
from, because I knew that, because 100, at a percent, you have 100%, and if there's 2 of that,
Audra, I like your work. Can you tell us where the 4 came from? Can't tell us where the 4 came from? All right, can anybody tell us where her 4 would have come from?
So, like, if you have 50, like, 1 times 50 is 50, 2 times 50 is 100, 3 times 50 is 150, and then 4 times 50 is 200.
True, but that doesn't tell me where the 4 came from. Like, you don't just magically put the 4 in there. Audra had a good thought. She just doesn't remember where her thought came from. Peyton.
So just think of that as 100, but it's 200. Out of 7, each one's worth a quarter. It takes 4 quarters to make 100, and then that'd be 100% of it. And then and then each quarter's worth 50 on that.
I'm still not hearing where the 4 came from. Where's the 4 come from? Kaylin, help us understand where the 4 comes from.
Because 50 goes into 25, 50 goes into 204 times.
It does, but that doesn't tell me why we use the 4. Where does that 4 come from? Dante.
Amount of groups of people.
Well, why did we choose 4? Why didn't we choose 5? 7, 10? Why did we choose? Oh, Audra thinks she remembers.
Wouldn't it be 4 because it's a multiple of 20?
Not quite, not quite. 4 is a multiple of 20. let's look at 75%. Dante, you got an idea?
1% is like 25% is 1. 50,
One what?
one part of the 50, and then 4
Ooh, not
is
quite.
the
Audra?
25, 425 equals 100,
Uh-huh.
and
You're getting there. You're getting there. 425 equals 100. What fraction is 75% then? There's where the 4 comes from.
yeah.
75% is 3/4. Because look, here she used times 3, right? First, she needed to know how many were in each of the fourths, right? So she divided by 4. Then she wanted 3 groups of those and got her 150 people. She knew what she was doing, she just couldn't verbalize it yet, and neither could any of you. You guys are all beating around the bush, but you weren't in the bush. You were just beating it up. Do you understand that 75% is 3/4? Yes, no? Because you would have 25, 25, 25, and 25, and that would give you 100. We understand that. Okay? So 75% is 3/4. So we want to, how many's in 1/4? 50. And then we wanted 3 groups of that. So 150 people. Okay? Number 7. We look at those steps over there. Who did number 7 for us? Who did number 7? Excellent steps, Abby. If yours don't look like that, you need to change it on your paper so it does look like that, or on your Chromebooks. Number 8, we have 350 goats in the barn. 50%, or 350 goats. 50% of them are in the barn. How many goats are in the barn, Dante?
175.
And how did you get 175?
What I did is I was trying to figure out what was half of 350.
So how did you find half of 350?
I started counting by 25 to figure out what.
That's interesting. You counted by 25s, okay. Chester, how did you find it?
Well, I knew that 75 plus 75 is 150, so I took 175 plus 175, and I got 1 plus 1 plus 2, and 75 plus 75 was 150, so I added 1 to over to 100, and I got 150.
All right. How did you find it, Eduardo?
I knew it was half of 100%, so I divided 2 divided by 350.
How about 350 divided by 2? Okay, all right. Number 9. What did we have to do before we could subtract? Piper?
Change 1 half to 4/8.
Yes. And what did you get?
1 and 3/8.
Yes, yes. And number 10, 8 divided by 9. What did you get?
What I did is I made the 9 into 90, and I got 10.
No, you would not get 10. What would we have to do for that one? What did you get?
I got 8 with a line over it.
8 with a line over it? Not just 8 with a line over it, but
8 tenths with a line over it.
yes, 8 tenths, 8 tenths repeating. 8/10 repeating. Yes. All righty, questions? Anybody? Okay, please get that recorded. And then we'll take a look at your answers to your assignment. One thing we talked about when we talked about writing a rule on whatever day we did this lesson, there were 3 parts to it. You mentioned what you were starting with, you mentioned what you were going to do to that, and then you mentioned what it was going to give you. Okay? We had number 2 and number 3, am I correct?
Mm-hmm.
And that was it, right? Okay. So by the 12th month, we were to figure out how much money the Gilman family would have spent based on knowing this information here. What was your rule? What was your rule? For number 2, what was your rule? That was 2 pieces. We need the third piece. Peyton?
Multiply the number of months by 35, get the number of months.
Yes, yes, that was the third piece. So, if we wrote an equation, and I'm adding this piece today to talk about writing equations. If we wrote an equation, M would be the number of months. The total amount of money spent might be T. Okay? So based on the rule that was just given, we would take M multiplied by 35 equals T. We have 2 unknowns. We don't know how many months we're going to have, and we don't know our total amount spent. But based on that, we can use this equation for any number of months and figure out the total amount of money spent. Does that make sense? So I can say, hey, in 48 months, how much money would I have spent? I can plug in my 48, I can figure out my total amount of money spent. So I can have 2 unknowns, but I know that this is my rule that I'm going to follow. Okay? So in 12 months, I would have filled in the 12 here times 35 equals T, which is what you guys did. You took 12 times 35, right? And your total amount of money spent was how much? $420. Okay? Did you understand how to write an equation for that? Okay? Let's take a look at number 3. Number 3, what was your rule that you wrote? Valerie?
The numbers that's plus by the 6.
pretty close, but you don't even like your own wording. Can you fix your own wording? Uh-huh.
The number of states multiplied by 6
Number of stacks multiplied by 6 is the height? Okay, all right. If n is the number of stacks and h is the height, can you try to write an equation right now based on that? Audrey, what's your equation? Any other equations? So we all have this equation? You had a different equation? Did you have this equation? Okay, that's the question that's being asked. All right. So no matter how many stacks we have, we can fill that in for n, and we can figure out what our height was. We have two unknowns. We can plug in for one of our unknowns and figure out the other. Does that make sense? Okay. Abby? Pardon? Okay. In this case, because we're looking for the height of 10 stacks, we would fill in the 10 for n. And h would have a value of 60, and our label is inches in this case. Okay? Questions on that? Anybody? All right. We are going to move on to the next section then. Graph and analyze relationships. It's going to feel like a real math class today. Yep. All right. When we take a look at this, we're going to take a look at graphing and analyzing relationships. Okay. Piecing together how to graph, which we've practiced that, and then taking a look at, once we've graphed things, how do we analyze that? It's fine and dandy that you can graph things and label things, but what do we do with that? We don't just say, oh, that's a pretty graph, okay? Because people really do use that information and take into consideration what is on that graph. What do I do with that? Because businesses do graphs a lot, and they analyze that. They make predictions. They take that information and make big decisions on that. Okay? They don't just go, got somebody to make a graph. Talk one up for you. Okay? But they use it to their advantage to make business decisions for the future. Okay? So as we take a look at this problem, Sasha's making hot cocoa for a party. For each mug of cocoa, he uses 3 tablespoons of cocoa mix and 6 fluid ounces of hot water. If Sasha uses an entire 18 tablespoons of container of cocoa mix, how many fluid ounces of water will he use? Okay? And again, you don't just do math all over the page. You organize your information in a table. Okay? We're going to graph it. because if we use a graph, we can quickly take a look at what we're going to need. Okay. Businesses would not necessarily do this type of a problem, but this would be something at your level that you could understand that could, as you get older, transfer over information to that. Does that make sense? I don't give you hard problems to start with. We work with something that you can hopefully understand. All right? Because businesses probably aren't going to be measuring out cocoa and hot water. Mrs. Allen might be, but not businesses, okay? Because I would care about my cocoa and making sure I had enough. All right? Yesterday I was wishing I had enough cocoa for everybody when we got back from our home. But I didn't. Okay? All right. So, when we take a look at our table, okay, we have to take a look at what our rule would be. What our rule would be, right? Okay. We know that we have 3 tablespoons of cocoa mix and 6 fluid ounces of hot water. So our first ordered pair is going to be 3, 6. 3, 6. Because cocoa mix is our x-axis and the amount of water is our y-axis. Our chairs have 4 legs for a reason. Thank you. We need more going on here, though. So in our table, we need to start thinking about a rule. Okay? What rule could we use?
Every 3 cups of cocoa mix, like, it'll go on to 6, and then 9, it goes up by 3.
So remember, our rule needs to be vertical, not horizontal. Okay? Yes?
For every cocoa mix, you multiply by 3. I mean, 2.
Add the 13. You get the amount of water needed in fluid ounces. All right. So we need to multiply the tablespoons of cocoa mix by 2 to get the fluid ounces of water. Can everybody agree with that? Okay. So we're going to multiply that by 2. So if we have 4 tablespoons of cocoa mix, how much water will we need? If we have 6. If we have 10. And if we have 18. 36. All right. So I did not go up by 1 each time here. I picked some random numbers going up though. Does that make sense? We can plot all those. 3, 6. What's my next ordered pair? 4, 8. The next one? 6, 12. My next one? 10, 20. And my last one? 18, 36. Okay. So we go to 3, 6. Oh, 4, 8 we can't do very easily, can we? Was that a very good choice? No. Why not? Yeah. What's the next one I should plot? 6, 12. 10, 20. Should I use that one? No. Why not? Yeah. What did my cocoa mix need to go in? Why 3? Yes, and my cocoa mix has to go in 3s. I'm going to do 3 scoops at a time, right? So can we just randomly pick numbers here? No, we need to read our information carefully and not just randomly. Oh, I know I can multiply any number by 2, because that's not going to work, is it? So we need to go back and reevaluate the numbers that we use here. We don't want to put 4 scoops of cocoa in. Because when we look at our graph, we want to go by multiples of 3. Okay? So we need to use 3, 6, 9, okay? So that would tell us we had 12, 18, 24, and our 36. So we already knew that we had 612 as an option. Now we have 918, 1224, and still our 1836. Okay? So looking ahead at your graph is going to be important, as you can see. We're going to do some random numbers we want to throw in there. $9.18 would be the next one we plot. $12.24 and $18.36. And then we can finish it up. Okay. So how many fluid ounces of water will he use if he uses the entire container of cocoa mix? So we look up here. It will tell us we need 36 fluid ounces of water. Okay? Questions on that? All right. Questions? Okay. Go ahead and try the next one on your own. Make sure you list the ordered pairs. Make sure you list your ordered pairs. Guys, the line I drew horizontally, I only did that to demonstrate. We don't normally have that line in there. You only have the line that connects your dots. Okay? Did you have the ordered pairs of 2, 6, 4, 12, 6, 18, and 8, 24? If you had a rule, what would your rule have been? Adam? Nowhere near the copper wire? If you had an equation, and the cost was D and the copper wire was M, what would your equation be? Write your equation down. Same. Yeah, D times 3 equals M. D times 3 equals M. Okay, now when you plotted your points, did you go 2 to the right and up 6? 2 to the right and up 6. Did you go 4 to the right and up 12? Did you go 6 to the right and up to the 18? 8 to the right and up to, was it 24? 24. And did you connect those? Okay. So how much copper wire do you need? 24 meters. Do we understand this concept? Are there questions? Okay. Do you start to see how we are combining lots of things that we've worked on all year? Okay? So we're taking bits and pieces of everything and meshing them all together. Okay, good. All right. Let's turn to page 574, please. As we take a look on 574, look at the headings that we know and tell me what this graph is about. Adam. About loose chili and hot sauce. Would everybody agree? Somebody didn't agree? What do you think it's about, Evan? Who has the highest chili? What? Who has the hotter chili between George and Lou? Anybody else?
I think the guy whose chili is spicier.
Whose chili is spicier? Is that what you mean by hotter? What do you mean? So would that mean spicier? Also, hot, spicy, is that what you're referring to? Kind of the same thing? Okay. Anything else anybody come up with? All right. So as we take a look at this, who do you think has the spicier or hotter chili? Hand up if you think it is George. Hand up if you think it is Lou. Why do you think it is George? Peyton. Okay. So you're looking at the fact that George has 12 teaspoons compared to Lou's 8. Anything else? Anything else? Just because George has 12 teaspoons and Lou only has 8, is that the only thing you should look at? What else might you look at? Who has the more actual chili? Yes? That's what you're looking at? So 12 teaspoons in 4 cups compared to 8 teaspoons in 8 cups. That might make a difference also. Okay? Does that make sense? Okay. Questions on that? Okay. When we look at graphs, we need to look at whether they are misleading or not. Misleading or not. By misleading, here's what I'm talking about. If this is the graph, do you think something happened quickly or slowly? How many think quickly? How many think slowly? How many think there's not a way to tell? All right. If you look at the line, and remember line graphs should change over time, right? It appears that in a short amount of time, something happened quickly on the rise, right? Yes? We don't know what this time span is though, do we? That makes sense? If we don't know what this time span is in here, we don't know if it really happened quickly for what we're talking about or not. That makes sense? Okay. We can change the time span, and I can take that same information and make it look like that. Because I can change the time span. I could say this is, in years, or days, or minutes, okay? But I can change the time span and change how I would have to graph it. Does that make sense? Okay? So take your height, for instance. Okay? Do your parents measure your height every day?
No.
They measure it what, once a year maybe?
Never.
Okay? If they measured it every day, it would look like you grew like this. Maybe, all right? But because they probably measure it maybe once a year, it's going to look more like this. Does that make sense? Okay? And occasionally there's going to be a whoop, because some years you do the big growth spurt. Okay? But if they measure it every day, it's going to look like you aren't growing much at all. Does that make sense? Okay? So when you look at graphs, you need to look at everything and what is being used on your x-axis and your y-axis. Because people can make it look like big changes or small changes, depending on the x-axis and your y-axis. I can make these big intervals or small intervals. Bar graphs, I can make these big intervals, small intervals. I can make the bars look really big. Oh, look at those big changes in between. Or I can have the intervals really small and, however I want to do it. I could go by thousands, and then it looks like there's no change at all between things based on whatever you're doing. Does that make sense? Okay? Or I could go by ones, and oh man, look how much change there is between them. If you're talking hundreds of things, yes, there's going to be a big difference between stuff. Okay? So be very careful about doing a quick look at bar graphs and line graphs. Read the information carefully. If you're doing a billboard and you put a graph on a billboard, how much time do people have to study a billboard? Not long at all, right? So if all you're looking at is the billboard graph, you don't have a lot of time to read the information on your x-axis and y-axis, right? So it could look like something went up quickly, or there was a lot of change in it, or there was a lot of difference in it. So graphs can be misleading. You want to make sure you read all the details in it before you make a judgment, or before you're persuaded one way or the other. Does that make sense? Okay. Evan, you have a question? They would use a line graph for that, by what you're saying. They would use a bar graph to do comparing, like compare the red cars to the blue cars to the green cars. Okay, they might show a difference in the sales, like color. They might show a difference in their sales year to year with a line graph. Okay, they might show it month to month to see which month they have better sales. Okay, and by doing that, they might want to look at what can we do to entice people to buy cars in January. Well, maybe people don't like to go out and buy cars in January because it's cold and they don't like to go out to car shop. Who knows? Okay, I don't know what car sales do. Okay, but they might look at their low month of sales year after year after year. Why are my sales low in February? What can I do to get people to come in and buy cars in February? Okay? Is there something special I could do? I don't know. I don't sell cars. Okay? I don't buy cars very often either, so I don't know. You know? I buy a car when I need a car. And that's the only time I buy a car. So, every 10 or 12 years, I go buy a car. And not in Dublin. And then they always want me to tell them all the details I want. I care about enough cup holders. And enough speed. I made the mistake once of not realizing that was important to me. And after that, I never made that mistake again. I didn't realize that was important to me until I didn't have enough cup holders. So the next time, I made sure there were enough cup holders. I sat in every seat. Is there a cup holder? There is. Okay, I like this one. Well, it's just a matter of there has to be one for every seat you're at. Like one vehicle I had, the middle back seat, there was no cup holder for it. Where are you going to put your cup? Nowhere. There was no place to put a cup. And people would travel. At that time, we had 3 kids, so the middle kid always was, oh, here's my cup, Mom. You know, what a pain. That was always a pain. Not that your kids were a pain ever to your parents. But, you know, that was a bother. Every time we went somewhere, if somebody had a cup, there was always a squabble over where they put the cup. And never made that mistake again. Everybody had a place to put the cup. Small thing in life, but, you know, if you travel, it's an important thing in life, you know? You go to ball games, everybody has a cup, right? Where to put the cup? You know, people are thinking strange, but they're worried about cup holders. Okay, well, travel with me, you'll worry about them too. How many of you take a cup with you when you go somewhere? See? You all need to pledge your cup, right? It's an important detail. And now I have to worry about having enough car seats saved. How many grandkids I got? How many car seats can fit across the back? Let's see if we can squeeze them all in. All right, question. Okay, we will have some practice on this. So let's do a practice we can do on this on our own. I think on 575, 2 and 3, and 576 all. And your computation, color computation thing is doing today. We have about beat that thing to death. It's doing today. If you don't have it done, that would be the first thing you finish up.
I'm done. I just need to check.
And it's going to go in your test tutor tray over there. You already have 12 out of 12 because you diligently organized in columns and showed your work and all that jazz.